Open your cerebral cortex and shift your lobes into upper beta phase, because you are going to have Bitcoin knowledge transmitted directly into your vestibulocochlear. Your host of Bitcoin Knowledge is Trace Mayer, an early Bitcoin advocate since it cost $0.25, but this is not intended to be investment advice. A doctor of jurisprudence, but this is definitely not legal advice. And an investor in core cryptocurrency infrastructure, including Armory, BitPay, Kraken, and Mitagio, but this is not a recommendation of those services. Here, you get fed via direct mind download with pure and free Bitcoin knowledge.
Welcome back to the Bitcoin Knowledge Podcast. This is episode 4 in a week with Dr. Adam Back. In this episode, we're going to be talking about the Lightning Network. Thanks for being with us, Dr. Back. And what is the Lightning Network?
So the simple version is it's a write caching layer for Bitcoin, proposed by Joseph Poon and Thaddeus Striger in a paper earlier this year. The idea is this will be able to sort of greatly increase the throughput, number of transactions per second of the Bitcoin technology, and allow us to get closer to micropayment levels of use and very low value transactions that have a number of advantages in being more efficient in their use of network resources and providing instant final settlement. So Bitcoin transactions, there are companies out there accepting unconfirmed transactions, but there's a significant risk that they can kind of get overturned or bounced. So by accepting those transactions, people are taking a kind of risk, and there is some possibility or ongoing risk that those unconfirmed transactions security level may degrade or slip as people start to attack things on the network. There's not that much assurance. And so for Bitcoin to get high assurance of transaction final settlement, you typically wait 1 or 2 block confirmations, which are at a 10-minute interval approximately. So, and, when you get into the investment grade amounts, if you try to make a deposit of Bitcoin into a Bitcoin exchange, typically they're going to want 6 confirmations, which is about an hour. So with the Lightning Network, contrarily, you can make a transaction of any value supported, and the settlement is pretty much instant. Sub-second, it's down to the network latency. And Lightning also makes much lighter use of network resources. The packets involved in a transaction, once it's set up, just flow peer-to-peer through a routing network. So it's much more like the internet at large, where you go to a web page and you download a page or something like that. And that information, the request and the response, flows using TCP IP routing through your device to your ISP to some upstream provider and eventually to the web service and back. And so, the round trip on those things depends on your network connectivity, but 50 milliseconds, 100 milliseconds, 200, stretching out as you get to countries with slower connectivity, and speed of light limitations kick in as well. So Lightning brings that kind of instant, much more bandwidth efficient sort of behavior to Bitcoin. It also supports still the smart contracting features of Bitcoin and the trustless nature of Bitcoin, which is a kind of surprising result that hadn't really been foreseen in this way. I mean, there were precursor technologies. So there's something called the payment channel that had been implemented by Matt Corallo with assistance from Mike Hearn as part of the Bitcoin J Java Bitcoin implementation. And those are more limited in nature because they are sort of unidirectional and point-to-point.
Is there a need with the Lightning Network to rely on centralized third parties?
So the way it works is the caching layer, the write caching layer that Lightning is actually some kind of peer-to-peer network where there are nodes in the network, and your payments flow through these nodes. Now, the interesting thing is the nodes, even though, you send a payment to the node and the node forwards the payment to the recipient or to another node that routes onto the recipient, is that even though they're handling the money, you don't have to trust them. There is no way for them to take your money or withhold your money. The worst case that could happen is a node could go offline, and then it might take a few days to get your money back. So there's a kind of time preference or delay risk. But people running nodes get small transaction fees and they have a profit motive to run the node. So it's expected that users would connect to multiple nodes. So there will be some redundancy and reliability built in, but no need for trust. And the smart contracting also works because actually every Lightning transaction is a full valid Bitcoin transaction. So at any point, either party in the transaction can send it to the blockchain and close down their participation in Lightning and reclaim the funds they're due. So that's also the mechanism that's used if a node goes offline permanently, that you can reclaim the money that was involved in that channel.
So when we're looking at scaling the Bitcoin blockchain itself, which is currently limited at 1 megabyte, there's a network limitation of, what is it, ON squared? Maybe you can explain that and how this Lightning Network can help Bitcoin scale in a technically appropriate way.
So in computer science, there's a terminology called a big O notation, which talks about the complexity, or so the way that resources are used as the number of users or the number of transactions increased. And it's a kind of stylized mathematical representation of how much resources are going to be used in the network as the number of users grow. And so there are different ways to look at the resources. So, is it per user? Is it per transaction? Are you looking at the aggregate use in the network? But anyway, if you boil it down, there's something like an ON squared thing going on, which is a kind of heavy scaling thing, which you wouldn't ideally want to get into, because basically if you ramp up Bitcoin and you put all of the world's current transactions onto Bitcoin, all of the derivatives trades, and there are companies doing millions of those per day, all of the wire transfers, all of the cash payments, all the share deals, share transactions, derivatives,
all the high frequency trading.
The high frequency trading.
Yeah,
I mean the Forex stuff. It's an astronomical number of transactions that are invisible to most people.
And these will be able to happen, as we'll talk about in episode 5 on sidechains. We'll be able to actually have limit orders on the blockchain. So we're talking about having trillions of transactions per year going on.
Yeah, I mean, I think there's a strong interest and utility to being able to do that kind of thing on the blockchain because of the new trust assurances it provides and the
atomic trading.
Right, the cost savings, reduction of trust, and possibility to re-architect or disintermediate some of the need for trust in financial relationships. So to come back to the scaling question, if we were to take all those transactions today and put them on the blockchain, we would probably be saturating the internet with transactions, because
it would make BitTorrent look mild.
Yeah, so apparently, well, I know Bram Cohen for some years now, who's also kind of
the founder of BitTorrent.
Yeah. So I mean, he has a kind of background in distributed systems and
in the economic incentives that go into the different resources being consumed.
Yeah, so there was a startup called Mojo Nation that was founded by Jim McCoy, and Bram Cohen worked there, and also Zuko Wilcox. And so both Zuko and Bram went on after Mojo Nation kind of came to an end to do their own kind of follow-on projects. And so Mojo Nation itself had this concept of agoric computing. So there were resources of storage and bandwidth and so on provided by the network. And agoric is a word
market,
for money and markets. And so the idea that there would be micropayments zipping around inside this peer-to-peer fabric that would be paying for service. And, so if there's a sudden increase in demand, the demand would be paid for by transaction fees to receive, web content, which would pay for more resources to be provided. Mm-hmm. So, in today's world, you could imagine paid with Bitcoin micropayments, an agent that's providing web service, and there's a high demand, so it goes and rents for itself more Amazon EC2 instances, and, the service grows to match the users, and it all works very smoothly. So there's much potential in agoric computing and micropayments to manage resources.
The novel daemon applied.
Yeah, so the problem for Mojo Nation is they didn't really have a micropayment system, so they kind of simulated it best effort in the network, and it wasn't real in some sense. And so what Bram did to make it a little more real but work with what was available with BitTorrent is a kind of tit-for-tat accounting. So the people you're pairing with, you sort of account for, well, he sent me 100 packets, so I'll prioritize and send him 100 packets, and as a peer-to-peer network.
That way you didn't get free riders.
Right.
Bitcoin.
So, I mean,
not as many.
Yeah. So it helped relieve the free riding issue.
Yeah, and get people seeding.
Right. And so, Bitcoin micropayments with Lightning can potentially get back to the fuller picture of solving denial of service and scaling services on the internet. So to come back to the scaling topic there, on-chain Bitcoin transactions scale ON squared, and there's been discussion recently about changing the block size, and whether we change the block size from 1 megabytes to 8 megabytes or gigabyte or something. That's firstly, a gigabyte would presumably cause the network to fail if we tried that right now, or only running a single node in a data center somewhere, or a couple of nodes like that. So firstly, that's not practical, and secondly, it doesn't really change the picture. If you go from 1 megabyte to 8 megabytes, you have 8 times more transactions maybe, but as somebody on Reddit said, model demand is infinite. If you actually want to pile on all the world's transactions, there is no plausible block size that you can choose that would make that possible. So let's not play around. Let's actually scale Bitcoin algorithmically in a way that can make sense. And so in some way, moving from 1 megabyte to 8 megabytes is a kind of a constant factor change. It doesn't change the game. And there's also a confusion about what scaling means. So scaling means how do the system resources change as you put more demands on it. So, this ON squared factor, that's what scaling is about, the characteristics as it grows. What people really mean when they talk about scale in a kind of colloquial sense is they mean, what's the throughput of the system? So changing the block size constant from 1 megabyte to 8 megabytes, okay, that changes the throughput, but it hasn't improved the scalability. And in fact, presumably the scalability went up by a factor of 64, very loosely, to get an 8 times throughput increase, which is a very inefficient way to go about getting more scale, and will sooner or later hit some implied bottlenecks.
Would you say that type of proposal is just poor computer science applied?
I think most people are understanding that, to use their own terminology, that it's kicking the can down the road, i.e. it's not solving anything. It's just creating a little bit of temporary reprieve while people work on some better technology. So Lightning is the better technology.
Yeah.
So, to the extent that you might want a reprieve, I think it's reasonable, but you want to go at it carefully and use validated parameters and not push it too far. Certainly not start to think that this is a long-term solution to anything, because it's not, and it won't pan out well for us if we think we're going to get to, multi-gigabyte or terabyte blocks to actually fit stuff on, because...
So if you're dealing with some undergraduates and you're teaching them as Professor Back, and you ask the question, is scalability the same as throughput? True or false?
False.
False.
Very false, yeah.
And yet some people might get tricked up with the question, like, which system has more scalability? The system with 1 megabyte or the system with 8 megabytes?
Well, they have the same scalability because the scalability is this ON squared factor, right? So now, of course, there are things that
they have the same scalability, but they don't have the same throughput.
Correct.
So,
yes.
So a lot of people who don't really have a solid understanding of the computer science might get that question wrong, because they might think, oh, well, 1 is less than 8, therefore 8 has greater scalability. When really the question is, no, it has greater throughput, but not greater scalability necessarily. Right,
yes. And actually there are costs and side effects. So throughput in Bitcoin, if we continue, if we focus on just changing that size parameter, it's a sort of security throughput trade-off. So by increasing the block size, you're inherently reducing the security of the system. So security in the sense of, Bitcoin provides a number of interesting assurances. Primarily, the main differentiators of Bitcoin versus, let's say, PayPal or something, which obviously people are free to use and is a competing system. So if you're not utilizing or valuing Bitcoin for what it's providing, it's quite plausible to use PayPal or a centralized system. And in fact, you can always build centralized systems on top of decentralized systems. So there's no reason why somebody couldn't build a centralized system on top of Bitcoin. And in fact, many companies are, and there is a kind of implied layer 2 on top of Bitcoin's blockchain layer 1 which is the kind of netting that goes on inside
exchanges.
Yeah, exchanges. I mean, it's even going back some years ago, it was understood that the transaction volume inside Mt. Gox, which was for a while sort of 85% of the market of Bitcoin exchange traffic, that would saturate the Bitcoin network multiple times over. So I don't know if people have like an exact number, but because some of these are dark pools and we don't know exactly, it's believed that the kind of layer 2 is accounting for something like 99% of the Bitcoin traffic. So the current throughput parameter is really just dictating how much has to happen in layer 2 versus layer 1. And what Lightning provides is a layer 2 that can provide all the assurances of layer 1. So you'll see people switch from the current layer 2 into a more trustless and secure layer 2 provided by Lightning. The other thing to say about Lightning in regards to scale is that it's no longer an ON squared network, it's a point-to-point network. So there's some kind of more linear or, scaling where basically the transaction throughput limit, if I'm sending to somebody else, is really down to how fast is my link, how fast is my network route to the person I'm paying, how much bandwidth does it have, and it's entirely plausible to do things like, stream a video or pay for a video conference facility or something per second. I mean, literally you could do that and that wouldn't be a particular problem for Lightning, whereas for Bitcoin that would be kind of insane today. And so that opens up the potential for many kind of micropayment use cases. And I think there's a sort of, if we have available micropayment system on a global scale, which is not tied to any particular fiat currency, so it becomes a kind of lingua franca de facto internet currency for paying for service, low-value transactions, to provide quality of service, or to pay for content production, that we could see some competition between that and the sort of advertisement model. So one of the problems you run into with the advertisement model is there's a kind of minimum fee that the existing payment rails can provide. So you've got the credit card and maybe there's a 30 to 50 cent minimum fee and some maybe one.
And so we've had to have the centralization of advertising. And I mean, are you getting towards like the 402 payment method not specified error in the web browser?
I mean, I think that's something very interesting and entirely possible once you get into this space.
Yes, I mean, we could go all the way from the very small, like Internet of Things. I interviewed Mr. Jennings from Filament, where he's going to be deploying a bunch of sensors, and you'll be able to buy weather data from these sensors or a whole bunch of other type of Internet of Things applications. So micropayments all the way from there through the web browser, all the way up to massive stock trades because of the smart contracts that can still go through these Lightning networks.
Yeah, so actually, I mean, the Lightning Network it was proposed in the context of Bitcoin, but actually it also applies to sidechains, which are an extension mechanism for Bitcoin. So,
in which we talk about in episode 5.
Yeah, so, I mean, without going too far ahead, but I mean, with a sidechain, you can add confidential transactions that we talked about in episode 3. You can add extended smart contracts to represent financial products, derivatives, structured products, and have smart contracts enforce them. And you can track other kinds of assets, so US dollars and shares, bonds, depository notes, and so forth, and write smart contracts between them. But the right caching layer that Lightning proposes will also work on top of sidechains. So we'll also be able to act equally as an acceleration layer for sidechains.
So when we're talking about being able to both extensify Bitcoin, adding new features and abilities to it, and then increasing its scalability, there's been significant progress being made between confidential transactions, the Lightning Network, and sidechains.
Yeah, it's things move fast in Bitcoin. It's like faster than internet time, I guess. It was only a couple of years ago that
Bitcoin was released.
Yeah, and I mean, sort of like, so I guess in the public eye for maybe 4 years or so, there was sort of, the media awareness was more on the Silk Road of things going back some years, maybe 2 years ago. It's kind of, news likes to amplify controversy. And so there was all that kind of discussion. But even in the last year and a half or so, we've seen a lot of sort of brand name, large financial companies set up.
Serious players.
Yeah, I mean, set up, like UBS has a blockchain innovation lab, I think, in London. And
same with Barclays.
Yeah. And, so many of the companies, if you just go look through the backlog of Bitcoin fintech news, there are a bunch of companies in the financial space and in the fintech space who are taking an interest in blockchain and smart contracts and how this can improve their cost effectiveness or reduce various types of, audit, reconciliation, trusts, and insurance costs.
You interact with a lot of these players that aren't necessarily as technologically savvy or experienced, especially with blockchain technology like you are, and they do raise lots of concerns or issues with you about Bitcoin's scalability. Just kind of not a short answer about it, but are any of those concerns valid, or do you think Bitcoin has got a solid plan in place to get these scalability concerns resolved and implemented?
Yeah, I mean, I think there was some kind of a misconception that Lightning was sort of vaporware and it might take years to arise, but the Lightning development projects, and I have a colleague, Rusty Russell, who's working on the Lightning Network, and he just did a podcast, I think, on Let's Talk Bitcoin, which was just out in the last week, on Lightning. And there are, there's a GitHub with the source code. There are now 3 companies. So Blockstream, Rusty Russell was working for Blockstream on Lightning. Obviously, the authors, Joseph Poon and Thaddeus Dreiger, are working on Lightning and participating on the development mailing list, which is open. And very recently, like a couple of weeks ago, there were 2 companies that came forward, and one of them released source code for another implementation, kind of pre-alpha stage implementation, and another one announced that they'd also been working on it and would soon release their source code. So things are moving very quickly, and it seems like there's some months of implementation work that's gone in. Rusty Russell comes from actually a networking background, so he's quite well known in Linux kernel development, as somebody who worked closely with Linus Torvalds and the other Linux kernel developers, and specializing particularly in the network stack in Linux. So he's really a kind of a network guru kind of personality. So we're very excited to see what he can do with Lightning routing and peer-to-peer network to really make that a very efficient and fast settlement layer, which allows users to route efficiently, because you've got to achieve some kind of efficient routing, and the routing involves not just network routing but also fee routing, because the nodes in the network are charging fees, and you want to find like a low cost in terms of fees charged route as well. So there's kind of 2-dimensional routing problem. So there seems to be quite fast pace of innovation in there, and there's a kind of timing thing where people are wondering about Bitcoin throughput. So going back to the block size thing briefly, blocks are maybe a third to 40% full on average. And actually Rusty as well had done some analysis of Bitcoin transaction data to show that I think it's 45% of the transactions that are in that, 30 to 40% are under $1 value. So that's not to say that, everybody should be able to enjoy Bitcoin at any value, and we certainly want to see adoption very widely and in emerging markets and so forth. But there are also services that are providing layer 2 low value transaction. They're optimized for low value transactions today. So if push comes to shove, there is like maybe 6 to 8 times headroom within Bitcoin's existing throughput limits. But the way to really get to high throughput is more with the technology like Lightning. And so, when people talk about the block size, they assume that if a change is made, it might take effect immediately. But actually, the previous soft fork, so for example, BIP66, which was a soft fork to fix a security defect actually discovered by Dr. Peter Willer, and fixed, to the benefit of all Bitcoin users. That was a quite serious security defect that was fixed there. That kind of soft fork upgrade actually took 6 months to deploy in the network. So as the block size increases, all the previous protocol changes of Bitcoin have been backwards compatible protocol changes, so-called soft forks. And there were unplanned things, but all the planned ones were soft forks. Now, changing the block size is, generally speaking, a non-backwards compatible change, so it's a hard fork. And so if anything, it's more risky and intricate. So, a 6-month time frame would be quite optimistic to achieve an upgrade. So, I think there's a kind of timing issue that if we had Lightning already deployed, we would be making different decisions about how to change the throughput and which features to prioritize. For example, it might be more interesting to prioritize a simple small increase in the block size and the relative check lock time kind of advanced feature that really helps Lightning be that much more efficient. So, there's a timing issue that maybe the blocks will start to get more demand before Lightning is ready, but it's quite a close call because, Lightning is well underway and there's good hope of within, say, 6 months seeing an alpha kind of, don't put money in it yet, but try it out, kind of alpha Lightning implementation for people to tinker with on the development side of things, rolling in towards kind of production version in a year's time. So I think for the kind of block size throughput discussion, it's better to focus on kind of the short term rather than the long term. I mean, some of the proposals have been put forward stretch 20 years out into the future or even further. And, the Bitcoin world will look quite different once we have Lightning running, let's say, within a year or two. So, for example, if we were to make a sort of interim plan for the block size to increase throughput modestly, so I'd suggested, for example, a compromise between the different positions of starting with 2 megabytes as soon as that can be deployed, growing smoothly to 4 megabytes over 2 years and to 8 megabytes over 4 years. And 8 megabytes is a kind of round number that has seen some validation in terms of network testing, though not very thorough, and also has been, the Chinese miners, as I understand it, really viewed 8 megabytes as the maximum they felt comfortable with right now, given the sort of network characteristics they're working with. So, to avoid creating problems for them and respect their wishes, I think 8 megabytes within 4 years would be something they might be able to work with. But certainly within 4 years, the world will look quite different. I mean, 4 years is essentially an eternity in the Bitcoin space, right?
Yeah, and especially if we have 6 to 8x headroom with the current throughput, doesn't it make sense to see what optimizations we can make under the current constraints? Because there's a lot that can be done to increase the efficiency of how we actually use the block size that is there. Yeah. But if there's no additional cost, then, we have every reason to be sloppy and otherwise do things that cost more in terms of space when it doesn't cost anything in terms of money to use up that space.
Yeah, certainly. I mean, I've heard, some of the people who propose sort of very aggressive rapid block size increase actually expressing it as a kind of Keynesian subsidy to get free transaction fees almost, or extremely low ones, because there is a supply and demand dynamic that people who actually care about and want the characteristics and trustless properties of Bitcoin, they're willing to pay a small fee to get that service. So if the block size is plus or minus effectively unbounded, there's an excess of supply, and so the fees will basically become free. And miners are in a competitive environment, so it's difficult for them to say, well, I won't take that fee, it's too low, because another miner will take it. So unless there's some kind of bounding, and so Lightning provides another dimension to it. So I think Lightning can potentially even increase the profitability for miners, paradoxically, because, if you can see, let's say, 1,000 or 10,000 times fold utilization of Bitcoin with micropayments, lower values, instant confirming transactions for very low fees, those still connect into the blockchain. So there is a channel setup blockchain transaction that goes into Lightning, the so-called anchor transaction. And when nodes go offline, there is a need to reclaim the transactions on the chain and to establish new ones. So there is demand for the blockchain, but if there are many thousands of transactions connected to each anchor transaction, there's a possibility to pay a larger fee because it's supporting, a much higher economic use. And so I don't think that really curtails anybody's use of Bitcoin, because you should think, I think you really should think of Lightning as an integrated write caching layer for Bitcoin itself. So this is just kind of the next step. I mean, in the early days of the internet, there was TCP/IP and IP address routing, and then we added DNS and we added, web's HTTP and other kind of service protocols in additional layers. And people don't begrudge, that they're not given direct access to IP, or the IP is expensive, or something like that. It's really, with the user level, you look at, can you make a payment? Is it cheap? Is it fast? Is it secure? Can you still do the smart contracting on it? So I think the answer is, basically everybody wins: users, miners, Bitcoin ecosystem companies, investors. If we get a kind of 2-layer scaling solution using Bitcoin for the anchor transactions and Lightning for kind of high volume transactions.
Ultimately we have to have some pricing mechanism in order to perform the economic calculation to determine how much value the Bitcoin network adds to society. And miners' fees, transaction fees are, that's an actual economic hard cost to use the network that goes to a random miner. So that's pretty much our only metric that we have to see what the market's willing to pay to use Bitcoin.
Yeah, that's right. I mean, in some ways, as the subsidy or amount of Bitcoins left to mine decreases, actually there is an assumption stated in the white paper that transaction fees would grow to provide, to fund security. So in some sense, the users via transaction fees, other than the subsidy, are paying for the security of the network that they're enjoying. And so if we see frameworks where transaction fees are zero, we may risk the security of the network, just in the sense that nobody's willing to pay for it and it becomes a tragedy of the commons.
So I mean, there just are a lot of different variables and factors to take into account when we're considering the scalability of Bitcoin, and also the technical differences between scalability and throughput. And it is not good computer science to not understand that distinction. We can make very, very poor choices thinking we need to increase the throughput of Bitcoin, thinking that we're increasing the scalability of Bitcoin when we're in fact only increasing the throughput.
Right. I think many of the more technical people involved in Bitcoin understand that it's just increasing throughput, or to use the terminology, kicking the can down the road. But the real scalability and high throughput comes from algorithmic improvements that reduce network resource utilization and add other advantages.
Well, this has been episode 4 of A Week with Dr. Adam Back. We've been discussing the Lightning Network, which focuses in on increasing Bitcoin's scalability and hopefully Bitcoin's throughput. Thanks for being with us, Dr. Back, and we look forward to the next episode, episode 5, where we will be discussing his brainchild, sidechains.
Thank you.
Be sure to get a copy of the free Bitcoin Guide at freebitcoinguide.com. Got a question or suggestion? Record your voice at bitcoin.kn. Don't be shy. To help the show, share bitcoin.kn with friends, post about it on Reddit, and otherwise spam the interwebs. Your iTunes comments and 5-star reviews are very important to us. Please continue tuning in to the Bitcoin Knowledge Podcast, where we release interviews with the top people in the Bitcoin world. Now take some choline and let that Bitcoin knowledge consolidate.